Good day everyone, and welcome back to the channel again, Learn with Anoze. Today we'll be looking at our second video in the Automata series. I deeply apologize for taking this long before making this video, and I promise to be more consistent in upcoming ones. On our last video, we were looking at DFA. We looked at the examples and exercises, and we said we were going to treat the exercises in this video. But due to time constraints or due to inconveniences, we'll be looking at the videos looking at the exercises in a separate video. We'll look at all the exercises of the Automata series in a separate video totally. So today we'll just be jumping into what we have today, which is NFA, Non-Deterministic Finite Automata. So our outline for today's course is, firstly we'll be looking at the definition of what an NFA is, look at the language in an NFA, also look at examples in an NFAs. So without further ado, let's go into the course. So what is the definition of an NFA? So it states here that a non-deterministic finite automata NFA is defined by 5 tuples, which is the same as all other automators. First is the finite set of states. Second is the sigma, which indicates the alphabets. Third is the transition function, which is indicated by delta. We have our Q naught, which is our start state, and we have our F, which is the set of final state. You might be wishing to ask, what is then the difference between this set of definition with that of the DFA? The only difference we have is the delta, which is the transition function. In our NFA or in our DFA, which you can see here, we are only transiting with the states that we were given and the symbols we were given, and the product of this transition is always the states, always back to the state we were given. While in this case we're going to be transiting with the same thing, the states and the symbols, but the product is going to be a function of the state we were given. We'll be seeing the difference in subsequent slides. Now, going to what is a language in an NFA. A language in an NFA is same thing as a language in a DFA. A language in an NFA, as defined here, is a set of all strings which are accepted by M. Let's say M is the NFA or the automata, and is defined by LM. So theoretically, a language is something or a string that transits us from the start state to the final state. In as much as it can get us from the start state to the final state, that is called a language. And mathematically, you can see here that let's say our string W is the string we are transiting with. So transiting from the start state to with the W in NFA, normally we would get to, when we transit with the string, we normally get to different different states at the bottom. So in those states, if at all our final state is available there, then we'll say okay, this is accepted. We'll look at examples of what I'm talking about in subsequent slides. So transition of an NFA. So a transition of a string in an NFA allows for a symbol in the sigma to be transited to 0 or more states from a particular state. So what does this mean? It means a symbol can be transited from a particular state to more than one state. While in DFA it is not allowed, in NFA that is allowed. So let's say we have example 0, our sigma being 0 and 1. Then we have something like this, where we have our start state A here transiting to B with symbol 1, and also the same A transiting to C with symbol 1. So as we can see here, we are having the same symbol transited to two different states from a particular state. And the other thing you are supposed to notice here is we have a symbol 0 which has not been used there, which is totally fine in an NFA, because a DFA you need to transit with both symbols for each state. While in an NFA you don't need to even transit with both symbols. You don't even need to transit with a particular symbol or more. As it is stated here, we can be transited to 0 or more states. Now in this case, 0 is not transited to any state from this state here. 0 isn't transited to any state from this state here, either 1. The same thing here, 0 or 1 isn't transited to any state here. So the only symbol that was transited to state as symbol 1 only, and it's only transited from a state. So you can see this is acceptable here in an NFA. Going to the next, let's see an example of a state diagram in an NFA. Now let's say this is our state diagram, having our start state Q0 and our final state Q2. We can see that the symbols of this automata is just A and B, whereby Q0 transiting with an A goes to two places. As you can see, it goes to Q0 itself and goes to Q1, and from Q0 transiting with the B goes to Q0. So you can see Q0 has transitions for A and for B. Then when we come to Q1, transiting with A, it goes to Q2, and transiting with B, it doesn't go anywhere. So it only has a transition for A, while for Q2 does not have transition for A or B. Looking at the transition table, you can see Q0 transiting with an A has a Q0 and Q1. Transiting with a B, it goes to Q0. Same thing for Q1, transiting with an A goes to Q2, transiting with a B goes to nowhere. And for Q2, transiting with either A or B goes nowhere. An example again, we are told to construct an NFA that ends with A, B. Now, according to what we said in the last video, there's a particular way I do solve this issue. Now, the language here is that the language or the string here that is meant to be our language must end with A, B. Therefore, what I normally would do is, my answer is, I'll put 3 dots indicating that there can be any variant of AB, 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 B, 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 A before the A, B. So therefore, the only most important thing for me to account for is this last A, B. So I know I have 2 important symbols for me to take care of. So what do I do in my own sense? If I have 2 symbols to take care of, I normally would have 3 states in my automata. So I'll have 3 states: Q0, Q1, and Q2. So after drawing my Q0, Q1, and Q2, the next thing to do afterwards is to connect these 3 states with the most important symbols I have, A and B. Then after doing that, I know that before A and B, there can be any variant of what ABs. Therefore, which state is before A and B? Q0. Then I put my loop here where I have any variant of AB before this AB. Now, this is also written in regex form: A union B star. This star meaning 0 or more times, meaning A or B can appear 0 or more times before this A, B. Then the language here is, as you can predict, this AB should be acceptable by this automata because it is ending with what? An A, B. So now let's see the transition tree in this automata, for this particular automata. So we can see that transition tree for this language in this automata, we can see that Q0, starting with Q0, if we transit with an A from Q0, because our language starts with an A, so starting with Q0, if we transit with an A, it goes to 2 places, Q0, then Q1. So the first place it goes to is Q0, then what? Q1. Then we are done with this transition with A, and our level, the level of the states in this level is Q0, then Q1. Then the next value we have is what? B. That means we are going to transit with B in both Q0 and Q1. Transiting with B in both Q0 and Q1, it takes me to Q0 and Q2. Q0 B is Q0, Q1 B is Q2. So now we are in this level and we have exhausted AB. The next value is A. So transiting with A in Q0 takes me towards both Q0 and Q1. Then transiting with A in this state takes me towards nowhere because Q2 does not have any transition to itself or to any other state. So we are done with A, and we are then this is we are not going to further transit with this again. Now this is the level we are at, Q0 and Q1. So let's transit with the last value we have here, B. Transit with B in this level, we are going to transit with B with Q0, transit with B with Q1. Transit with B with Q0 goes to only Q0. Transit with B with Q1 goes to what? Q2. So we are done with our transition. So you can see in transition we have A, B, A, B. This first part takes me to what? Q0. And the other part A, B, A, B takes me to Q2. So at this level we are having two states. One not being our final state and the other one being our final state. In as much as we can get a final state amongst the states we transited to at the final level, then that string is what? Acceptable. And in this case we can see our final state is what? Q2. Just like the definition we gave for language in the previous slide. It states that when we intersect this final state that we got to in this level, if we intersect it with the final state in the automata, it should not be what? Null. In this case it is not null because we are having a final state Q2 amongst those states that are in this level. Now going on to another example, we are told to construct an NFA that starts with 1 and ends with what? 0, 0. And I think you can actually pause the video and try attempting this question. Now going on, this is very easy again to treat. Since we are going to start with 1 and end with 0, 0, we can equally write it as this 1, then there can be any variation of 1 and zeros before 0, 0. So therefore what we need to look at here is three symbols 1, 0, 0, which are our most important symbols to look for. Therefore if we are having three most important symbols to take care of, how many states are we going to have? 4. That is right. Q0, Q1, Q2 and Q3. Q3 going to be our final state. Then what is the next thing to do? Yes, get it right. The next thing to do is to connect these states with our symbols. Connecting Q0 to Q1 with 1, Q1 to Q2 with 0, then Q2 to Q3 with 0. Then what's next to do? Where we have our variation here, or where we should have our loop, is just after 1 then before 0, 0. Which state is after 1 and before 0, 0? Q1. Therefore our loop is going to be under Q1. So if we can test any language here to see if it is going to fall under any language here to see if it's going to fall under Q3. So we have languages, let's see 1, 0, 0, 0, 0, 0. Again it starts with a 1 and ends with a 0. You can try drawing the transition tree to see how many states you get at the lower level, and you see if you can find a Q3 among those states. So this is going to be the end of today's video, and I please urge you to leave a like for this video, subscribe to the channel if you are just a new viewer of the channel, and if you are a returning viewer, thank you very much for staying put with us, and also leave a comment in the comment section below.